Test environment management is something that many companies consider an unnecessary expense. When allocating project funding, it's common for test environment management either to be disregarded or seen as a cost that should be avoided or at least drastically reduced. This approach introduces considerable risk to the quality of projects and to their timely delivery. Environment management is a critical process for software development and testing, and, if not conducted properly, test environments could become chaotic or unusable very quickly. Test environment management is the set of processes defined and carried out to help in understanding the need for IT environments across the development lifecycle, establishing proactive controls to ensure the environments are provisioned and serviced in a timely manner, ensuring that they are used and shared effectively, and, when no longer needed, that they are decommissioned promptly. An effective and efficient test environment management process consists of many activities. Some of the most important include managing environment knowledge. It's important to know what the IT and test environment landscape looks like. Unless the platforms and end-to-end architecture are truly understood, it's difficult to manage and coordinate them. Knowledge management can begin with a discovery exercise, ensuring that development, testing, and production environments are sufficiently documented. This should include key configuration items such as environment groups, systems, environment instances, components, microservices, relationships, and test data. As requests for new environments are received, and as changes to existing environments are needed, these must be analysed before they are built and made available. When a request for a new or changed environment is received, the requirements must be turned into an environment design solution based on what is in scope. Options include building new or reconfiguring existing environments or sharing existing environments. Provisioning also includes determining tool requirements and setting them up, and creating and managing various artifacts for reuse and purposes related to compliance and audits. Once created, environments must be configured and finally integrated into the overall environment landscape at the appropriate time. It may also be necessary to manage the initial provision of test data. After environments have been provisioned, development and test teams will require support from an environment management team. This support can include incident and issue resolution, configuration and change management, access management, and general environment-related activities such as batch running, file transfers, or data rollback operations. Both development teams and software testing teams require access to specific development and test environments throughout the software development process. Often, test environments must be shared by different teams or even different projects, and a way is needed to avoid the potential resulting conflicts. One way to do this is to have a system in place that captures and manages the demand for environment usage, including an environment booking system. The demand information collected in this way, together with planning and coordinating activities, can be used to help schedule and allocate resources appropriately. Comprehensive reporting and timely communication with stakeholders helps to keep environment management running smoothly. Useful reports can include supply and demand metrics, including forecasting, booking and change requests over time, numbers of outstanding requests, release booking status, availability of shared environments, data on current and historic configurations, upcoming maintenance downtime, asset utilization, actual usage, and current health status. Nothing in life is perfect. Things go wrong from time to time, and this is true for environments just as much as anything else. Issue management is a process that analyzes unexpected environment problems, allocates them for rectification, and tracks them to resolution. It should also involve some form of root cause analysis as part of an attempt to prevent similar issues from occurring in the future. Environment management, properly conducted, is important because poor or missing environment management can lead to expensive consequences. Test environments can become different from development or production environments by having inconsistent versions of operating systems or hardware configurations and varying software versions and patches. The greater the differences, the greater the probability that the final product will have more defects. Infrastructure assets that are inefficiently managed can result in budget spikes and may delay or otherwise hinder the testing process. For example, root cause analysis of incidents and defects becomes more challenging when there is misalignment of test and other environments. It's common for test teams to clone or extract production data and use it for the purposes of testing. This approach can be time-consuming and is error-prone, and it may not meet data protection policies. Often, the process is not sufficiently change-controlled and cannot be audited. Communication plays a critical role in all phases of the software development lifecycle. Poor communication can result in misunderstanding at all levels, including of the business requirements, and may result in failure to identify important defects. Poorly configured defect tracking tools can themselves cause additional issues. A controlled process should be in place to manage the defect lifecycle. If this is not done, defects may be assigned incorrectly for resolution and important information missed, resulting in wasted time and resources, as well as injecting additional defects at later stages. Recent research has shown that almost a third of the effort of a project team is consumed by environment or data-related problems. Testers spend, on average, 1 day per week identifying and resolving environmental issues. That's effectively a 20% reduction in test resource availability. And that over a third of environments are not properly or efficiently utilized, and the costs associated with non-productive environments can be very high and are not green. By appropriately employing good environment management processes, both the costs and time wasted as a result of these statistics and examples can be dramatically reduced. Properly conducted, test environment management helps organizations to speed up stable software releases by establishing collaboration between members of development and testing teams, capturing environment demands and establishing a simple and transparent environment utilization procedure, and engendering cooperation by planning and scheduling resources and controlling their life cycles. Ultimately, test environment management aims to streamline delivery by providing stable and correctly configured environments in which to execute tests or replicate defects. It provides records for and accountability of environment activities. This means there's a greater ability to control and forecast usage, with the possibility of significantly increasing environment utilization. Having more visibility and control of environment status and configuration can reduce unplanned downtime and rework, resulting in fewer project overruns in terms of both time and budget. Having specialist resources handling environment management reduces or removes pain points for test teams and management, allowing them to focus on their core roles. This can also provide a cost saving around resources. Knowing that test environments and data are being properly managed by people who know what they're doing increases confidence in both development and test outcomes. By employing the services of a dedicated test environment team with focused expert resources, allows rigid controls to be established and removes the burden of environment and data management from project managers and test teams, allowing them to focus on their primary roles. By standardizing environment configuration and software release and change management processes, compliance is ensured by introducing a level of control over what changes are made to the environment. Managing access to environments and resolving conflicts between projects and programs provides assurance that only approved resources have access at the appropriate time and with the correct permissions and privileges. Clear and effective management of assets, utilization and costs ensures the non-production estate is as streamlined as possible. Many of the benefits I've mentioned will result in a reduction of unscheduled outages and loss of testing time, which in themselves improve environment stability. Increased environment documentation and visibility enhances overall confidence in systems and enables provision of a high-level view for senior stakeholders. By making critical information available in a suitable context to stakeholders ensures there's a level of consistency of knowledge across projects. A reduction of risk of deploying into production through greater control of change impacts will lead to fewer post-implementation issues. And effective handling of the post-project decommissioning of redundant software and hardware components leads to more effective environment cost management. Environment management can be implemented in many ways. How it should be done depends on several factors, including the abilities and skills available in the organization. Talking very generally, implementing environment management involves creating processes and procedures which define how the constituent elements of environment management will be carried out. So there will be processes and governance procedures for such activities as managing knowledge about the environments, provisioning them, managing demand, providing ongoing support, managing and resolving issues, and reporting. But the level of complexity and breadth of these processes will depend on the number and type of environments to be managed. So before any processes are defined, a discovery exercise should normally be undertaken to understand the current environments and any existing management processes and tools. This provides information about the scale of the problem, on which recommendations can be based about the best way to manage the environment landscape. Having gathered sufficient information, appropriate processes for control and governance can be created. These processes and controls, together with the appropriate supporting tools, help to minimize the risk of encountering environment-related problems. Another purpose of discovery is to find out what the current environment management process consists of. There's no need to reinvent the wheel if there is one already there. However, a wobbly wheel could be tightened, or a broken wheel could be repaired or swapped out for an improved model. But enough of the metaphors. Once an appropriately simple or complicated set of processes, in other words, the environment management service, has been defined, it can be deployed. This is usually best not done with a big bang approach, but by introducing new or updated procedures and tools in discrete packages over a suitably extended period. If an external consultancy, such as Experimentus, has been employed to help define and deliver the new service, it can be introduced over time, initially by utilizing the consultancy resources to run the service, and simultaneously by training in-house staff to enable a transition to run the service fully by the organisation's own employees. This is an important part of what experimenters do. We can resource the centralised environment team exclusively if requested to do so, but we find it normally serves the organisation best when in-house personnel are involved and eventually take full ownership as the service is implemented and transitioned to them.